Cool. Alrighty. Oh, is it just over there?
Oh, I can just yeah. Okay. And that should do it. Oops. There you go. Nice.
Alrighty, yeah. Thank you all for coming out. This quarter we're going to be doing a workshop series on Google Cloud Platform. We'll get into the details in a second. But before we do, let's quickly go over the agenda for today. So we're going to be starting out by talking about what ACM Cloud really is. We're going to talk through what cloud computing is at a high level. Then we're going to get into the details of what Google Cloud Platform is, GCP. We're going to talk through some of the permissioning with Google Cloud. It's also very similar to all the other kind of major cloud cloud service providers, and that's known as identity access management. Then we'll be talking through one of the simplest services with Google Cloud, called Google Cloud Storage. And then finally, we're going to be doing a couple demos, have some time for work, and then we're going to do our social. So before we start, let's quickly just introduce the officer team. So yeah, I'm Satyan. I'm a junior. I guess my major is computer science and engineering. And a fun fact about me is that I have a twin, but he's not in CS, and we're not identical. I guess we can just go down the line.
Okay, I'm Arun Singh. I'm a third-year computer science major. I am a newly inducted officer at ACM Cloud, and yeah, I'll be hosting a workshop. Fun fact about me, I climb flat walls as fun and call it rock climbing.
Yeah, hey guys, my name's Nicholas. I'm a second-year computer science major. I'm also an officer here at ACM Cloud. I guess a fun fact about me is I have an older sister who also went to UCLA 9 years ago for CS.
I'm Daniel. I'm a junior, and a fun fact about me is I play violin. Not well, but I play it.
Okay, awesome. So let's keep going then. Oh, there we go. Okay, so what is ACM Cloud? I'm assuming most of you kind of know what ACM Cloud is already. We have our mission statement on here. I'm not going to read it, but basically, the things that you need to know are that we are currently offering two major kind of ways to get involved. One is our workshop series. So we're planning to do a cloud-related training workshop series with the three major cloud providers. So currently that's Azure for Microsoft, AWS, so Amazon, and Google Cloud, which is what we're doing this quarter. And we're going to kind of rotate through those every quarter, right? Because we have 3 quarters. And then in addition, we're going to be doing a research project. Daniel will talk more about that in a second. And then in the future, we're looking to try to get involved with some of the kind of consultant companies in the LA area to give folks hands-on experience applying like the skills that they learn working with those cloud providers in like an actual kind of industry setting. Okay.
Yeah, so this is the research project. So just drop that form if you're interested. And so basically the topic this quarter is going to be leader election algorithms. And our goal for this quarter is just going to be to create or improve a leader election algorithm and publish a paper at the end of the quarter. And 2 approaches we're going to take is either creating one completely from scratch, or we take an existing algorithm and improve it in a certain way, either run it slightly faster in certain situations or slightly less memory.
Cool. Alrighty, and like I mentioned before, let me do this. We're running our Google Cloud workshop track this quarter. So the way we've divided it is into 6 workshops, with the first 3. This one is going to be the intro. We're going to have one on virtual compute and one on databases. So those first 3 will be the fundamental core services for Google Cloud or any other cloud provider. And then the last 3 will be where we're kind of building upon those, as well as specific services for building a chatbot. So we're going to be leveraging Dialogflow, which if you don't know what any of these are, don't worry too much. We're going to get into the details, as well as like a specific version of Dialogflow that works with generative AI. And then we're going to kind of build our app and also talk about the future of cloud in our last workshop. So the idea is that on the right here, I have a little example of what interacting with this chatbot will look like. It's not necessarily going to be a banking account chatbot, but it's going to be something of this form. Okay. So any questions on what ACM Cloud is? Okay, let's keep going then. So what is cloud computing? So if you've been to our workshops before, some of these slides may look a little familiar, but hopefully the concepts are either new to you or this really hammers home what cloud computing is and why it's really valuable. So let's just say we have a new, totally original idea to create our own AI chatbot here, right? So assuming we have like a kind of a really simple version working on a local computer, right? We can like ask it questions and it gives us good answers. How do we actually share this with other people, right? To like actually create a business? Well, the major concerns for any new business, like if you want to create a startup, for example, right, would be these three things. You need to have some staff to help maintain your code, expand it, and like address any issues that come up. You're going to need some sort of hardware to actually run your application and handle requests to it. And then this one is a little overlooked sometimes, but you need some sort of space for you to work in, your staff to work in, as well as for your hardware to sit in. So that leads us kind of to the major costs, monetary wise, that we need to consider. So I just kind of talked about some of these at a high level, but more specifically for hardware, you're going to need some sort of way to store your user data. So for example, with a chatbot, specifically like an AI chatbot, right, you probably want to have lots and lots of data so that you can actually train it properly. So that's a lot of kind of physical kind of storage devices sitting somewhere in some warehouse that you're going to have to pay for. You're going to need some sort of servers to handle requests and actually update the data if there needs to be, if something's incorrect or something like that, as well as network hardware to communicate between those servers and the storage. You're going to need staff of a variety of professions, specifically like software developers to maintain your app, hardware technicians to maintain the storage devices as well as the servers, as well as security for the building, maybe sanitation folks, whatever other kind of like maintenance stuff you have to do for the buildings and for the staff. You're going to need to pay all of that out of pocket. And then finally, for your actual buildings, you're going to need to talk to lawyers, maybe real estate agents to kind of negotiate some sort of contract to get into to actually rent a space. And then you actually need to pay for the building renting, as well as keeping the building in like workable condition. Okay, so let's just say you pay all of that out of pocket, right? And now we want to grow our business, right? So we have one location. Generally, what that process would traditionally look like is this kind of six-step process where we forecast like an increase in demand. So we know that we want to get a new location. We need to scout out that new location, enter into some sort of contract for the property, buy the hardware for that new location to run, install the hardware, and then migrate our software to the new location. But so this is a very lengthy process. And because market demands shift all the time, it can turn out that even if we do this, we may end up running a loss for the short term. Okay, so like, why am I bringing all of this stuff up, right? Well, just sit tight for a second. We're going to talk a little bit more about another concern that you would need, which is specifically regarding reliability and availability. So assuming you have this, right, you've expanded your business to two separate locations, you also need to account for the chance that there may be a failure at both locations or one location, right? So generally, what you want is to make sure that you have some sort of redundant hardware. So for example, if you're storing critical data, you can store it in two separate locations so that if one of them gets nuked or something, you still have the other location, as well as a way to test the process when something does fail. So when it actually does fail, you know that you have a process in place that works, so you can recover smoothly without any issues. And that's kind of what this diagram here is showing. Okay. And then another concern when you're starting your business is security. So obviously you don't want people to steal your user data or your training data or whatever other private data that you have. So you probably want to have some sort of physical security in the building to make sure people can't just walk in and take it, as well as digital security, normally in the form of encryption or some sort of VPN if somebody is like connecting remotely to your servers to access that data that's private. Okay, so obviously there's a lot of kind of concerns, right, that we talked through. And not all of them are relevant to a software developer, but when starting a business, right, all of these kind of come into play. So the better solution, the hint here is this is a cloud, is to use cloud computing. So specifically, what cloud computing allows you to do is hand off all of the hardware management to a third party. So the idea is we can still kind of configure the hardware as if we owned it, but we don't actually have to manage the physical hardware at all. So for example, like all of these companies here have hardware sitting around the world, like in different warehouses, right? And they maintain it and manage it such that we can essentially just rent whatever hardware we want, wherever we want, and then configure it to use the specific operating system or whatever kind of specific configuration we want, and run our software. So kind of quickly running through each of those concerns before, with cloud computing, you pay as you go. So there's no kind of steep upfront costs, which makes it really appealing to startups, right? Because you can kind of get off the ground running very quickly, and you don't have to pay for a lot if you have a small amount of customers. In terms of staff, you still need to pay for your software developers, but you don't need to pay for any hardware maintenance. And you may not, depending on if you have a physical building, you may or may not need to pay for a physical security and like other staff. And then another advantage is that your buildings can be a lot smaller now because you don't need space for hardware. You just need space for your developers. In terms of scalability, cloud computing is very, very advantageous because it allows you to scale instantaneously, more or less, with just a couple clicks of a button, internationally. So you don't even need to worry about any like kind of legal concerns that you ordinarily would have to work through yourself and may take months. And you can scale up and down on demand. So ordinarily, with the kind of on-premise model, if you want to scale down, right, maybe demand is decreasing, you would have to kind of find a way to negotiate some sort of rental transfer agreement or sell your property. But with this, you just press a couple buttons and you no longer need to pay for the extra resources. Okay. In terms of downtime, cloud computing again is very strong because it allows you to scale up, configure scaling up automatically when there is a failure. So, and you can test this out very easily without having to actually purchase additional hardware and run those kind of configurations yourself. Additionally, by leveraging the existing networks of these cloud providers, right, which are very expansive, you can store your data in multiple locations without, again, having to purchase those locations yourself or having to manually go to each location and configure it. You can just do it all from just sitting on your couch, I guess, and just pressing a couple buttons. Okay. Lastly, with security, there's no more physical security for your data because it's not sitting in something that you own, but you still need to worry about digital security. And again, this generally takes the form of encryption. So these cloud providers are really keen on providing automatic, and generally it's become the norm to make it default, both static encryption and encryption of data in transit. So if you're downloading a file, it'll be encrypted, or uploading a file. So lastly, the last thing to kind of really consider here is how are we going to manage permissions in terms of users, right? Because if I'm like a hacker and I want to like read some data, assuming the data is in AWS, right? Like, can't I just kind of pretend to be an actual user and access it? Like we could just try to use credentials, like the login credentials, right? But those are generally not super safe. So there are some additional considerations that cloud providers take to make sure that we're really managing permissions well, so that that data is not being leaked. Okay, so here's kind of a general overview of the advantages of cloud computing. On the right are the advantages, and on the left are I guess disadvantages of going with that old on-premise model. The reason they call it on-premise is because it would have been like you're essentially running the hardware on your business premises. Okay, but any questions on kind of why cloud computing is so advantageous? Yeah, go ahead.
I'm still kind of confused with what exactly a CDN does, or
Uh-huh.
it's this model of computing.
Sure, yeah, good question. Sure, yeah, I don't think I've really touched on it too much, so that's a good question. So an example of kind of what a CDN would look like is this image on the right here. The idea is that there's some sort of network that has a lot of like edge locations spread throughout the world. And basically what they can do is they can either cache content at those edge locations, so users kind of around the world can very quickly access a resource, or they can actually do, like sometimes these are not just caches, but they can actually have some sort of compute like capabilities, so they can like write back to a database, that kind of thing. But yeah, so AWS, they have their kind of their own CDN that's native to their like cloud computing environment. Google has one as well. And then there are also other CDNs that are not affiliated with a cloud provider like Cloudflare, maybe you've heard of. But essentially they all do the same thing. They're just there to kind of speed up access time when interacting with any sort of content over the web. Does that make sense? Okay. Any other questions? Okay, at a high level, like, I mean, this is great for business owners, right? But like, why do we care as developers? Well, so cloud computing has become very, very popular with like enterprise companies. I think it's like 80% or 90% use cloud computing for their like backend. Many common companies that you probably interact with, like Gradescope, uses AWS, I believe. Disney Plus runs entirely on AWS. I'm pretty sure Canvas runs on some sort of cloud provider. I don't know which one exactly. But basically, any sort of software that you would interact with, I think generally they'd be called like software as a service companies, run on some sort of cloud backend. So they're not paying for their own hardware. Okay, so if there are no other questions, I'm going to pass it off to Aryan to talk a little bit about Google Cloud.
All right, hi. So first of all, let's just understand why we're using Google Cloud and what is Google Cloud. So Google Cloud is like a suite of cloud computing services similar to AWS, and it has like a lot of management tools that is exclusive to Google Cloud Platform. The other thing is it's one of the leading industry cloud providers, and I think it has a good share of majority share in the cloud computing market. And the other thing about GCP is it offers all of these features. So as a developer, if you want to work on cloud, all you need to have is a Google Cloud Platform because you'll have storage, databases, compute. In fact, Google Cloud has like a code editor inbuilt online. So you don't even need to have a Visual Studio Code on your laptop if you're working on cloud. And it has multiple applications, not only like Internet of Things or big names like Cloud AI. Companies sometimes just use this to have data stored on cloud. And the best part about cloud, I think, which I like the most, is the regions and zones. So one of the main reasons people and companies move to cloud is because, let's say I have developers in Mumbai and I'm working on the East Coast. So how do I send files fast? And like when I say files, these are like big data structures. These are like CSV files of millions of lines of codes. The only thing is, as Satyan said, with CDNs, these files can be cached continuously and you have faster access to data across the world. So in retrospective, cloud is for companies who are like have big data centers and they want to mitigate all of that. Because if I had a data center in Mumbai and I'm accessing from the East Coast, that's not going to work out and it's going to be slow. While on cloud, it just caches on CDN and you get faster access to everything. That's basically what GCP is, and this is what we'll be covering. Moving forward, I'll pass it to Nick to explain the IAM roles and what actually entails in the technical part of Google Cloud Platform.
Yeah, so far we covered a lot of benefits to why GCP is really useful. Another important thing for this is a kind of more general concept, not specifically just for Google Cloud Platform, but more towards like cloud security, is for identity access management. So essentially, this is just for controlling user permissions when logging into a server. Like say you're like a company and like you need employees from around the world logging into your servers to like access resources such as like emails or files, things like that. Obviously you don't want people to just like SSH into your server and just do like willy-nilly whatever. Like if like we're UCLA students, we could SSH into like the CSNET servers. But if we try running like sudo rm/rf to like delete every single file that's stored onto their computers, they won't actually allow us to do this. So this is kind of like the idea behind identity access management, also known as like the principle of least privilege, where essentially you just want to deny like users every single permission by default, and you only let them do what is absolutely necessary. So essentially like everyone just gets like as little privilege as possible for them to do whatever like you assign them to do. Like for if you have an employee and they need to do like certain tasks, you only want to give them say like read write permissions to certain files and nothing else. And then IAM also allows for quick and accurate identity verification. So it's very useful if you run like Google Cloud Platform or even like other things like AWS, for like maintaining security and to like make sure like no one can just log in, like a hacker can just go in and like ruin everything basically. So this is kind of like an example of what it would look like if you had like an IM JSON file to kind of like configure what kind of permissions a user could have. So don't worry too much about like the actual details, but essentially what's just important to know is the effect, action, and resource, where effect is just saying like, oh, like this user can kind of like, you're allowing them to do a certain thing, like you're either like allowing or denying something. And then action is kind of like what you can get. So S3 is in this example, some kind of object that's related to AWS. And it's just saying it's allowing you to get this certain file like .get object. So it's allowing like this user to perform this kind of action. And then the actual resource is like the actual like file that they'll be able to get. So if you can see like the picture of the car, that's essentially like what file that they're basically able to kind of control. And then, yeah, back to Aryan to talk about more of like the storage part of Google Cloud.
Okay, so with all the nitty-gritty and everything we have said about Google Cloud, how do we actually store information in Google Cloud? Like, what's the physical function or device that we store in? Because locally it's a hard drive, but in Google Cloud, it's called buckets. So what is a bucket? A bucket is basically like a container, and you can store files, objects, and anything you want in it. And in Google Cloud, each bucket has a unique name. So even if I write a bucket called ACM test one on my Google Cloud platform, you guys won't be able to access it because it's that individual. Second thing is buckets can be assigned classes based on data frequency and cost evaluation, which basically means if they want to scale down or up, you can fix the size of the buckets just to reduce your own cost. And that's how companies end up being cheaper. And geographic location is, even if your CDN continuously caches, if I'm accessing primarily on the West Coast, I'll choose the server as US West 1. And that is the primary place where the actual bucket will be stored. And once a bucket is created, it's basically immutable. You cannot change its name, location, or permission. So that's one thing about Google Cloud Platform that makes it very secure. Because it's basically like a hard drive on the internet. And how does buckets actually work? For this, let's just take this example of these pictures and these people. So buckets are like objects, and each object has a unique metadata, has a unique ID, and author and version. All the objects in a bucket, all the objects go under bucket and have a global namespace. Not across all AWS, it's across all GCP, all cloud platforms. And to name a bucket, you can only use lowercase letters, dot, and hyphen. That's just the standard way of doing it. And that's how we do it. And inside a bucket, you also have folders to organize your things. So bucket is basically your storage container. And moving forward, all the files that you want to store are stored in a bucket. So this is exactly how you would like to visualize a Google Cloud platform, that we have objects, dog, alpha, Ellie, and everyone. And they're in these folders called doggers and people. But these actual things are stored in buckets. So thinking of a file system management, your bucket is basically a hard drive, and these are basically your files and folders. And moving forward, we're gonna like show you how you can access your buckets, how to create a project, and what goes behind the scenes. Any questions before we actually get to the technical part of this workshop? About, yeah?
I had a question on the slide showcasing the map of different storage locations that Google Cloud has.
This one?
Yeah, that's the one.
Yeah.
You explained how if you have a really large file, for example, a large CSV file.
Yeah.
That you've uploaded on the East Coast. Other developers in Mumbai can easily access it.
Yeah.
Where does that caching, when does that caching process occur? Does it occur when you first upload the file, or does it occur when a request for Mumbai is made? How does that specifically?
So as far as I remember, and take it with a grain of salt, but caching is like a periodic thing. So once like I'm trying to access a particular server, the files that I'm continuously accessing keeps on getting cached under these different servers. That's why there's the low latency, and that's what makes cloud so unique, because you're able to access files anywhere. And it's just Google Cloud continuously caching it to make sure that you have the files at your ease. The other thing is there is slight latency, but much less than if you had like a big data center. Does that answer the question?
That kind of makes sense. So let's say I'm a developer in Mumbai.
Yeah.
And
Let's say you're
Oh, yeah.
Sure. So we're saying that the data is like a Google Cloud Platform data storage center body.
Yeah.
It'll have a cached version of this really large file. Does that mean the large file exists in multiple different places at the same time?
No, it's just like, because it's caching it continuously, when you're trying to access it, it's just faster. Because caching basically means it will get like most of the chunk down, or like a parts of the file down, or like the metadata of the file down. And as soon as you ask for it, it's still gonna curve from, let's say, West Coast or East Coast. But because there's so many servers and it's continuously caching, because of the metadata, it's much faster.
That makes sense. So it's not like a large file, because 1 million, that would be very infeasible, especially with multiple different locations. So it's parts of the file. I'm understanding this. Thank you.
Yeah.
And so to add on to your questions, also really interesting coordination problem, since like even if you grab chunks of the file local to your local like nearest server, if you want to propagate changes to that file, you'd also have to propagate those from your caching server to the main one, so everyone else knows about it. And there's like many different algorithms to do this, and you know, you can choose different ones depending on your circumstance, what you want to prioritize.
Yeah, last thing related to that, there's also a notion, like if you're not working with flat files, you're working with a database. There's a notion of like a read replica, where basically it's just for reading, but the entire file will be saved, and will be periodically updated, if there's like a change, in like a separate location. But yeah, I think what Daniel was getting at is if you want to do it right, then, obviously it gets a little bit more complicated.
All right, any other questions about anything we have covered so far? All right, so moving forward, we're gonna work out how to actually access Google Cloud. So there are two ways to access Google Cloud. One is the web browser, the other is Google's own CLI. It's pretty easy to install, it's pretty useful when you're using it, and it's pretty organized if you have an experience with Linux. And the basic industry strategy is sometimes to use this. So the two resources first we'll be covering is the actual command line projects. So just to show you, this is how it works, but like, we're gonna switch to a terminal to actually do these commands and see how it goes. Let's just say I already have a terminal here. Okay, so one of the few.
So your screen sharing.
Oh, okay, I'll just start this share. Okay, so starting with, you first need to have an auth login into Google Cloud. So the way you do it is gcloud auth. As soon as you do that, you'll get into this kind of page, which basically asks you and prompts you use your Google Cloud to log in. I should just share the entire thing. Yeah. And logging into it basically just connects you. It's not that big of a hassle. And this is how you connect your CLI to now your Google Cloud account. Now, once you're logged in, how do you create a project? Because the thing with Google Cloud is, before you do anything, before you create anything, you need to have a workspace. Your workspace is your projects. And the command for that is gcloud, which is what we'll see often, projects, create, and the name of your project. So that would be, let's say, workshop day 1. Usually the project creation takes a bit of a time, but what you can see at the bottom is the project being created. There you go. And similar to how you do it, if you guys have had background with Linux, just to see how projects have been created, you just do gcloud, projects, and list. And list out all the projects that I have created coming from here. Now, working in the particular CLI, there is you have to tell the Google Cloud that I'm working on this project, which is, you can do it either by the name or the project number. Let's say you want to do it by the name. So let's just pick up this project. As you can see, the project that I just created hasn't been uploaded in the list, because creating projects and updating do take a while. So for the process of the workshop, I'm gonna just work on my first project and show how it's done there. So to set a project, we are working with this one. All you have to do is gcloud again with config set project and the name of your project. Oops. Oh, I have to use. There you go. So I'm switching to a different project because that project has spaces. And again, in Google Cloud, the convention is you can't have spaces and you can't have capital letters while naming your projects. Awesome. So now we are in the project. It's configured to us. Let's actually get to creating buckets where you can actually store files. So to create a bucket, again, the simple idea is just to go. Oh, I'm sorry.
I tried running these commands in terminal and, they're not working. Do I need to set up the CLI first before I can run them?
Yeah, so if you go to the official documentation, there's a gcloud CLI that you have to install first, and it's just like unzipping and running it.
Okay, it's a zip file.
Yeah, it's a zip file, so it's a tar file. It's a tar file, yeah. But yeah, also in our README, we also have it mentioned there how to use it.
Yeah, I just posted the link, like just now. So we'll also, I think once Owen goes through the demo, the first part here, have some time to do like work time. So you guys can kind of set that up and make sure everything's working on your end.
Yeah.
Thank you.
So moving forward, how do you actually create a bucket? Similar to everything, the gcloud is the way you actually preface everything. And you have to mention this command: storage, buckets, and create. Also, like any other file system, Google Cloud has a particular file convention, which starts with gs:// and that's gonna be whatever after this you write is gonna be a bucket. And let's just name it bucket 1 ACM workshop. The only reason I'm making the name this complex, because if I say bucket 1, there's a highly likely chance that somebody has taken that name already, and because it's immutable and you can't change it, you have to do it like this. Actually, I'm gonna switch my accounts right now. Yeah. So start again, because that project hasn't been configured, and with Google Cloud, because there you go. So now to actually get to the creating bucket part, and this is the bucket we are creating. When I run this now, it does create that bucket called GS bucket 1 ACM workshop. Are we clear on how this is going about? It's just a bunch of commands, but the basic idea is you should be knowing these because it helps like actually just work off the terminal. Now, a bucket is created. How do we actually know it again? So gcloud storage is basically telling the CLI that you have to look at the storage part of it. And when we do ls, it mentions all the buckets that have been created in this file. All these commands are in the slides and you can look over them again, but just to have a basic idea of thing, these are the few commands to create buckets, to create a project, and how to get into a project to create a bucket. And lastly, the one thing that's more important for today's workshop is copying files from your desktop to the terminal. So Google Cloud has the function called gcloud storage CP. And after that, it's just whatever file you want to do, just its raw path. For me, it would be users. Oh. Also, when you're copying the files, you also have to mention the bucket name, which I forgot. So let's say this is the bucket name. Again, prefixed with GS, because that's how Google Cloud recognizes it. And there you go. That's the steps. Just to create a bucket, start a project, and copy, for this example, one file onto this. Any questions about that? All right. So going back to slides now, we can. So we have gone over like the 3 basic projects: creating a project, get a list of project, and set project. Before starting a project, you do have to set the exact project which you're working in. And this is how it shows as seen in the workshop. And these are the commands for listing things regarding bucket. Create a bucket, view bucket, copying files from local. This part of it, which I have copied, is just your file name, followed by your actual bucket name. And listing files, which is just ls recursive. The only reason we do like recursive is so that it calls every file in that particular bucket. And yeah, to end off it, GCP bucket basically holds everything that you stored in a singular bucket, and you can organize and control the access to the data. But buckets cannot be nested. Folders in a bucket can, but like bucket itself is the storage container. Any questions regarding that? Yeah.
Notice in the readme, it says like GS. Is it the same as like G Cloud storage? It's just a shorthand.
Yeah.
So it's a shorthand for G Cloud storage.
Yeah. So there are multiple ways you can do it. GSUtil is just like a tool to do it similar way, but the G-Cloud way of is a G-Cloud storage and then all the part. Any questions? All right. Now, for creating the bucket through the GUI, it's pretty intuitive, but if you click on this link, you can see all you have to do is go to console and go to buckets, and it's as simple as clicking a button, which just says create a bucket. So you have multiple ways to actually do. Yeah, there are multiple ways to actually build the same buckets. There are multiple ways to do things like that. But these are the 2 things that we would like for you to work on the work time. And if you have any questions, please feel free to ask them. Yeah. So let's take 20 minutes to have a work time. If you need help setting up your G-Cloud CLI, if you have any questions with buckets, and then we can move forward with it. Is that good? Thank you.
Yeah, so there's a README that we shared. That should give you like a step-by-step if you're kind of looking for direction. yeah, I think for now, like Oren said, we're just gonna take like 20 minutes or so, just to kind of see if you guys can get set up with Google Cloud or with the CLI locally, as well as an account. And then try uploading and downloading files, through the command line or through the browser. And then there's also a little bit at the bottom about hosting a static website. I think Oren's gonna do a little demo at the end about that. But if you get done, and you're looking for something to do, you can follow those directions.
socializing a lot with Benson.
Okay.
Benson was like.
So let's go
"Hey,
ahead
here."
and do this quick demo where we're going to be deploying a static single file HTML
Yeah, Benson
website.
likes it.
So to do that first, this time we're going to be using the browser instead of the CLI. So we're going to click on this navigation menu, and we can either click on more products here, or if you have a pin, you can search for Google Cloud Storage. But in this case, let's scroll down to storage and click on Cloud Storage here. Now we'll see that we have our buckets that we created earlier. We could create a new one. Actually, let's go ahead and create a new one for this. So we're going to call it ACM Cloud Demo 1. Press continue. Here we can choose regions. We're going to just do one region, but you can get away with just using the default settings. I'm going to select this US West 1
that's
Oregon
fine.
because it says load
Yeah, I
here
didn't know
too,
it's called connection.
and I want to help out the environment. Okay, and then let's go ahead and leave this setting the default. We don't need to change the storage class. We can uncheck this box because we want public access. For now, I'll leave it checked, and then I'll show you how to disable it. But if you want to uncheck that, you get a head start on a later step. And then finally, let's click create. Okay. Here we can, again, it's asking us if we want public access. Let's uncheck this and click confirm. Okay, so now we have, if we click back, we would see that we have a new bucket. So let's click on it, and we'll see that same page we just saw. And you can see if you click on the right here, we don't have any files currently in our bucket. So let's go ahead. Ryan, where's your file saved? Like if I click upload files,
It's on.
that one there. Okay. So basically what you want to do is if you clone the repo that we've posted in the Discord, you'll want to upload your index.html file, or you can create a new file, call it whatever you want, as long as it has this .html extension, and give it some sort of content in it. Before we start, let's click on this. I'm going to click on download, and then we can see it's downloaded the file and opened it up in my browser. And this is what it looks like. This is the content. So if I close this, which is my downloaded file, and click on here and click on permissions, we can see public access here, and it says not public, and then it says prevent public access, right? So even though we don't, if I click on this prevent public access, it's going to restrict public access. So this is what would happen if you didn't uncheck that box. So we want public access. So we want, I'm going to click this again, which is akin to unchecking that box like we did the first time. So this basically gives us the possibility of having public access, but we still need to explicitly give everyone read access. So to do that, we click this grant access button. Here we want to basically give this to the principal is the person that's receiving the permissions. So we can give it to all users. And then here we're going to want to do cloud storage read, I believe, reader. storage read. Hold on. Just give me 1 second to pull it up. What's the exact name? This should be on the README if you have it open, but I don't. Okay, it should be storage object viewer. So leave off the Google. Or leave off the cloud. Sorry. Object. View or not reader. There we go. So we want read access, but not write access. Okay, here it gives us, because since we're giving it access to everyone, it's kind of a large, like it only wants us to do it if we're sure, right? So we're gonna do it though. And then lastly, if we click on objects, click on our file here, and then click on edit access. Hold on a second. There we go, public URL we have now. It took a second to propagate the other change. So if we click on this, it'll open up our website in the browser, in this case, just as a static file. So if this was like a text file, it would also open it up. And we can actually use this as a full website, right? This is publicly accessible without the need to download anything. You could open it up on your phone if you wanted to. Yeah, and if you wanted to, you could also add some like JavaScript style and CSS styling to the site. It isn't a full kind of like it's just kind of a static site, so the file is static. Like you can't have like a login feature or anything like that. But in future weeks, we'll show you how you can with a different Google Cloud service to really leverage some of the power that Google Cloud provides. Okay, so with that, we are going to go ahead and wrap up. Whoops, sorry, give me 1 second, not this. And do you know where the slides are? Okay. Is that the one? I don't think that's the. Okay, awesome. So yeah, with that, we are going to go ahead and wrap up. So yeah, if you guys have any questions when working with cloud, getting that first stuff set up, feel free to ping us on Discord. We're more than happy to help. Otherwise, we're gonna go ahead and head into our social. So I'm gonna go ahead and stop the recording and we'll move forward.